Good afternoon, session chairs and delegates. So I will be talking mostly about what ISRO is doing in the renewable energy. You might be thinking why ISRO is involved in the renewable energy. First question will be that. But as you are knowing, there are many things ISRO is doing for the launching the rockets and doing the many satellites building as well as application of that. Turned out that when we are doing some research, then we found that this is one of the major area where our satellites, mostly geostationary as well as polar satellites, it can be used very well. I will coming up on that later on. So this is just a use of the energy in India, as you know. By satellite itself, you can know how much energy is being used, because this is only the lightning data. So by light itself, you can see this much energy is being used or being required by the country. If Indian scenario, that yesterday also there were talks maybe there, and then today also, total renewable energy itself contributes 17% approximately of the total capacity, that is around 57 gigawatts out of the 30 gigawatts, this is as late as the June of 2017. So this is the part of this year itself 57, and then we are going about the 2022. Then we need around 175 gigawatts. That is a huge power requirements, as well as we want to generate this much of renewable energy. So first thing, for that purpose, you should know how much potential we have. Forecasting will be coming later, but just first thing is how much potential we have from all over the Indian region, over the inland region as well as in the offshore region. Because inland region we have only the limited land area, so you cannot go more than that. So for that you have to have something near the coastal region, that is vast coastal regions of India. We have 7,000 kilometers of the area. So you can do one potential, one very accurate potential estimation you can do, as you very well know, by the ground truth data as well as the in situ data sets. But you cannot have the in situ or ground truth data each and every place. First thing is that, as well as you cannot have the continuous data, because you have 1 year, then next year you have to change the instrument, and then intercalibration of the instrument is the problem, because if you are having instrument of the one company at one place, another company at another place, there will some biases will be there, there will the errors will be there. So that is a basic advantage of satellite is there, because you have the uniform data and well calibrated data, because one satellite is launched, it may 5-6 years it will be there, and all over the globe it will be giving the same data sets. Whatever errors are there in the beginning, that errors will be there up to 5 years also. So that way you have the well calibrated, well uniform data, and that you can have the lot of data also, because every day you are getting data from the polar orbiting satellite at least once in a day or twice a day. But with the geostationary satellites, which are giving every half an hourly data. So like solar data, what we are getting every half an hourly till last year. But this year I will show we are having the every 15 minute data, because we are having two satellites, INSAT 3D, INSAT 3DR. So solar satellite data, solar insolation, you are getting every 15 minutes now. So that way you can have the well calibrated, very frequent observation of that. In that that I was telling how you can get what are the sources of the renewable energy, and how you can tap from or get the potential from the space data. If you see this wind energy, we get from the spectrometer, what we call a spectrometer. This is a polar orbiting satellites. It gives the wind speed and direction over the ocean surface, not on the land. So from that we are having the data. US satellite was there, QuickSat, this for 1999 to 2009. More than 10 years data was there. Then we have our own ISRO'S satellite, OSCAT, what is called Ocean Sat Spectrometer, 2009 onwards. Last year we learned SCATSat, this is again a spectrometer, which is working since last year and will working towards the maybe 5-6 years. Then we have a operational chain of these spectrometers. So like that you are having continuous data of the spectrometer. By that you can get the wind speed and direction. So using wind speed and direction from the satellite data, you can get the wind power, wind energy. That I will show some of the pictures as well as discussions on that. Then if you go to the solar energy, then we have a geostationary satellite, as I told. Earlier was the Kalpana satellite was there. Still it is after more than 10 years, it is still working fine. So we are using Kalpana data. Then INSAT 3D, INSAT 3DR, which was launched last year, 3DR. So lot of data what we are having, that's what I am telling. Every 15 minutes data from this is having for solar energy. Similarly, because wave energy is still being not tapped much in the India, but as well as outside also not much because of a technology issue. But we should know what is the potential of that. So for that, we have altimeter, another radar we call it, that is a radar altimeter, which gives the sea level, anyhow the one parameter, important parameter for the climate point of view. But parameter what we use here is the significant wave height, that is used for the wave energy. So we have a Saral Altica, our ISRO CNS initiative, then JSON, Topax, lot of altimeters are there. So we are using those for the wave energy. Then some other energies are there, ocean thermal energy, tidal energy, salinity gradient wise also we can get. So those things we are not talking much, but first three I will be just briefly talking about that. So as I was telling, so if you go for the solar energy, from the geostationary satellite top you see, we have the Kalpana, Inset 3A, Inset 3D, 3DR, then we will have Inset 3DS afterwards in 1920 onwards, as well as the GI-SAT next year we are getting geostationary satellite. So lot of satellites are there which, from which we can get the potential for the solar energy. Not only the potential, but based on the satellite data, we are also trying to predict, because every 15 minutes data is there, so you can have the predictions also based on satellite data. So this is based for the solar energy. And for wind energy, as I told, basically it's LEO, it is written, LEO means low Earth orbiting satellite, that is polar satellites, like Scatometer I told, OceanSat 2, Megatropics, these are the satellites. And then in addition to that, if you see the bottom, you say the one RISAT we call it, RISAT synthetic aperture radar. This is the very beautiful satellite which gives a very, very high resolution images. This is we are using for the wind. I will show one or two images of that, because you can get very, this resolution is 1 meter. So you can 1 meter, 2 meter resolution, but only problem is that it is only, suppose it is only one satellite, so it is a repetitivity is quite less. So if we have many satellite like that, then we can go very near the coast and get the energy potential using this type of satellites also. So for first I will talk about the solar energy. So solar energy, what we are doing, we are having the potential from the satellite data, then we are doing the predictions using the satellite data itself, as I told, as well as numerical modeling. And then we also have developed an app for that purpose. So anybody, if you are having a mobile, he can use that app. He want to know the solar potential at that location, he can immediately get for that location or any other location in India that he can do. As well as if now, since 3 months back, we started giving the predictions also. So what is the prediction for that particular location, that also one can do. And this is the satellite I was talking about, how we are using. Mainly this is an optical band, water vapor band and thermal infrared band. Resolution is 2 km for the visible band for the Kalpana. And then now the new satellite in the bottom you see Inset 3D, 3DR. Then resolution is half, it is, that is 1 km in the visible, and thermal it is 4 km. So this data we are using for the solar energy. So this is just a brief flow diagram how we are using. We are making the cloud mask and the clear sky, and based on that algorithm what we have developed based on the thermal infrared as well as the visible infrared visible band, we have developed the scheme. From that we get the instantaneous insolation that you see the right hand side in the bottom. That is instantaneous insolation, means every 15 minutes you get the insolation. Based on that you can get the daily, weekly, monthly insolation can be computed, and then it has been computed. So based on that we developed this algorithm for the insolation for getting the hot spots over the India using the Kalpana data earlier. And this is since more than 10 years data is there, you can say instantaneous as well as daily insolation. So based on that one can get the overall how much potential is available at each and every locations. So this is one example of that. And based on that, as I was telling, now on our website, this is a website is called bottom you see www.vedas.sec.gov. On this website we are keeping all this data operationally, and one can anytime he can use it using this website also, or using the app, mobile app he can use. In this case only left hand side I am just showing that monthly how the solar energy is being changed. That is just an example of that. In addition to that, because if you go on the land, you have the shadow from the buildings. So that type of model also we have developed mainly for some of the smart cities. So where we have the shadow analysis we did, and based on the image, what area will be on the rooftop will be available for your rooftop generator. So that's what app is also there. So one can use that very well. And then this is the app I was talking about. In addition, this is the app on mobile. In addition to that, we have the digital atlas of the solar energy potential from our satellites, and rooftop, as I told, solar energy potential in 98 smart city and 60 solar city has been estimated already. An approach has been developed for high resolution solar power forecast. And left hand side bottom you see the map. This map is just showing that how many locations till now people have accessed this app to know the solar power potential. That is 3 months back only, and still we have so many hits for the knowing the solar power potential. So this is the right hand side, this is the solar calculator, and these are just some of the example of that. If you go to that, you can give your location, either from your location, if your GPS is on, you can get, otherwise you give your location. I give example for just one particular location, and then it will calculate what is the monthly average of the each area for that particular area, what is the monthly or yearly average, and then also at that particular, this is one tabular form you can get. In charted form also you can get how much insolation is there, what is the temperature, because it will also depend upon the temperature, not only the insolation. Then map of that area particular where you want to know, this also is there. And in addition to that, the forecast, 72-hour forecast that we are giving presently through this numerical model. I will talk about that also a little bit. So this is the forecast how we are giving using that. And this is one of the forecasting method we developed based on only on the satellite data. As I was talking about, we are having the satellite data every 15 minutes. So based on the only satellite data of the last climatology and last 2 hours, we are generating for the 1 hour ahead how good is the forecast of the insolation. So based on this one example of that, how we have developed this, this is we are showing only for our own area, because we are comparing for the our own campus. So this is SAC campus, Space Application Center campus. So there we had a PV as well as then we have whatever we forecasted. So this we are just showing. In addition to that, we have also estimated this for our using the Ministry of Non-Conventional NIW, NISC also, and then we have exchanged data with them, and then what satellite is giving and how the actual values from the ground, what is the requirement is there. So that we have showing, and if you see the bottom, what is the good match between the SRR data of the MNRE as well as satellite data. This is a very good, excellent match is there. So this type of comparison not only we are doing, because if we do, we can have somebody can say you are doing something manipulation also you can do, but we are giving the data publicly. Anybody want to do, they can validate the data and how and they can give us the feedback. If anything something we have to improve, we are improving that upon based on this whatever data we are getting. So not only the satellite data, next is the based on the numerical model. That is what one numerical model we are using WRF. Dr. Patra was morning he was talking about that. In this we are giving the 72-hour forecast, every 3-hour forecast, and every winds are every 15 minutes. Now we started giving winds every 15 minutes also, and resolution is 5 km in this case. Major advantage what we are talking about, why we are doing, we are not a forecasting agency as such. We are not operational agency like IMD in the meteorology and inquires in the ocean science of the Ministry of Earth Sciences. But our aim is to how to improve the forecast. And improve the forecast, major thing is Dr. Kumar was morning telling, major thing is the data requirement. If you have a lot of data, your forecast will be better, because you are assimilating a lot of data, and whatever data, more data you are assimilating, your forecast will be better. So in our case, what we do, whatever data is coming from the ground truth, any of ground truth, a lot of data is coming, like some of the agencies also, some state agencies also giving the data, a lot of rain gauge, lot of wind data they are giving, as well as NIW also data we will get. So these data we are going to assimilate, as well as in addition to that, some of the data which are not going to the operational agency like MOES presently also. You see the left hand side one graph, it is spectrometer data, as I told, we launched last year, and this data is still in the case of the validation calibration, because this data will be calibrated, validated, Before we tell it is the quality of the climate quality, what we call the 1.5 meter per second or 1 meter per second error data. But we are experimenting with this data, we are assimilating this data also. So when we are assimilating more and more data, and you can see this data has been assimilated in the left hand side graph, and how much impact we have gone in the positive impact, because red color you see in the top is a mostly positive impact. So if we are assimilating this data, so we are getting more and more positive impact, that means our forecast is getting much and much better. So this is one example of that, using this all this type of assimilation data, we are using the giving the forecast, and this forecast is being compared. This forecast is for the short wave flux given by the model, and this is data from the NIWA, and this is the presently validation of this data using the number of towers we have used for this validation, and this is just an example of the one present forecast. So this also being validated, and this is the website I was talking about. One more website, what we call is the Meteorology Oceanographic Satellite Data Archival Center, where we give all the satellite data. Presently, whatever satellite data is coming, it is openly being given to the public, mainly for the research purpose only. That is the only criteria we give for research purpose, not for the commercial purpose. So research purpose data can be used, people can register, they can use the data for research purpose, and they can publish the paper. So when we are giving satellite data, so we want to, that is the purpose when we are doing satellite data analysis, we want to see the impact of that. The impact of that, how you can judge yourself, that's why we are doing forecasting. We are not doing operational forecasting, that's what I told, we are not doing operational forecasting because of this reason. We want to judge the data, we want to assimilate the data, and then when it is certain stage, it has come, our assimilation schemes, new assimilation schemes we have developed. So based on that, we provide the experimental forecast also on the atmosphere as well as the ocean side. Even nowcast, because nowcast generally is based on only on the satellite data, not on the numerical models. So nowcast we give on the cloud burst and the heavy rain. So these type of forecasts also are being given using this, and this also a mobile app where we can see Mosdek weather app, where we can get the instantaneous images of the satellite data. And this is the I was talking about when we are having two satellite inside 3D, in the top you see, and 3R. These are merged. Then you have the every 15 minutes, these are the cloud motion vector winds, which are being used in the numerical model for the improved prediction, because we are giving 3 level winds, high level, mid level, as well as the low level winds. So these winds are being generated using this satellite, and these are being afterwards used in assimilated in the numerical models. And so when we come to the wind energy, the wind energy, mainly from satellite data we are doing for the offshore, because satellite data is able to give only the offshore energy. This I'll just skip. These are the. So for that, as I told, we are using the 4 satellites. QuickSat we used, then OSCAT, Oceanside Scatometer, ASCAT, that is European satellite, and our own high resolution RSat data. So these we are using for wind energy. These are the some computation how we are doing that, and these are the total monthly maps for the wind energy, wind fields at the 10 meter height, and because your mast is at the 80 meter, then we are computed for the 80 meter also, how the total potential will be there. For this we are showing for different months. And this is the left hand side annual wind speed, then for the 10 meter and 80 meter. Then how is the total energy will be there, or power density will be there at different heights, that is showing. And when we are talking about the overall area, but you cannot tap the whole area. So here we are showing over the particular region based on the MNRE classifications, how these classifications are coming of the different type of power density distribution. In addition to that, if you see this graph, you see the near the coast, because some of the area where you cannot have the this wind power generators. So some area you have to exclude, that is visible seashore exclusion, as well aviation, due to aviation you have to exclude. When all these restrictions apply, you cannot go much beyond also. So in that case, if you see the Arabian Sea side, you see the contour graph. The contour is showing only that depth, because you cannot go beyond 1000 meter depth also. So this is the area where you can have the energy. So based on this criteria, you can get which are the potential sites for offshore wind farming. So these type of things are being generated. And based on that, what are the different technology for wind turbines are there, so which can be used for that purpose. Based on all this data, we have generated how much total energy can be tapped. So if you see the right hand side, second one, then annual power generation, this is too much, too large than that. What is the requirement itself? That EPG by RE ratio, if you see 2.2 itself, for the 0 to 35 meter itself, you have a lot of energy. Everywhere you can tap it. So similarly, for different depth, we have estimated. And this I was talking about the very high resolution when I was talking. So because the spectrometer, as I told, the left hand side, it cannot go very near the coast. So it gives the resolution of the 10 kilometer, 6 kilometer like that. But very high resolution synthetic picture data, right hand side you see, you can go very near the coast. So very near the coast, if you want to estimation, then this type of satellite can be used. And how based on this very high resolution, how we are getting the winds, because there are different algorithms are there. And based on that, we have generated how much energy density can be available near the coastal regions. So these are the wind resources, as I was telling. We have done similarly for the solar as well as for the spectrometer using the offshore region, and right hand side you can see using the numerical model only, because the satellite is not able to give at the surface. So based on this, we are giving the energy for the offshore and onshore, and the numerical model, as I told WRF, we are giving the forecast also for the 3 days forecast using that. And based on that, we are in process of developing overall whole web page, where one can go to their particular site. He can number of turbine, which type of turbine he can choose, and then you can just see on the what type of potential is available. So this is under development. Maybe within 1 month we will be launching this also. And wave energy, I will not talk much, because this wave energy is still in the nascent stage. As I told, we are using altimeter data for that. Altimeter is able to give the wave height. So based on the wave height, we are able to generate the wave power based on the satellite data left hand side, and right hand side you can see based on the actual numerical model. So both when now we are combining all those both the things. So based on that, we can give the wave power potential using this. And then these are some of the later future we can do. This is based on the thermal gradient, how much energy will be available. So these are the just examples. We are not in much in that presently, and ocean wave power anyhow. And this is a wind calculator, similar to solar calculator. The wind calculator is also available, where you can go similar to that. You can give location, or you can get at a particular location also, tabular form. What is the wind speed, wind power, wind direction, chart you can get. Then forecast also, 72-hour forecast for this purpose. At the surface, as well as the 950 millibar and 850 millibar. Presently we kept at the 3 heights. And this is the website I was telling, Vedas. You can always visit. Here the app, you can give earth left hand side, see earth observation, polar science. And that if you see that there is the tab is the new and renewable energy, where we can get all this information about that. So this is the screenshot of the website where you get the energy, so solar energy, then wind energy, this wave energy. So this is the overall, just I wanted to talk about this. Any questions?
Yeah, thank you very much, Dr. Kumar. So I think you mentioned a lot, a big variety from research to the app finally in my pocket, so very nice. And by the way, because you in the first sentence you said maybe it's surprising that ISRO has to do with renewables and solar. Of course, I guess ISRO has been one of the first PV applicator for your satellites, apart from pocket calculators. So, which questions do you have?
Sir, the solar calculator app which you mentioned, I'm not getting the data for the present location. If I'm giving the coordinates, I'm getting the data, but I'm unable to get the data for present location.
Just after lecture I can show, because your GPS may not be working. Because if you see any other location, it will work. It will
Google
show.
Maps is working in my phone. So.
Any other location you give?
Okay.
It should work. Because morning itself I had tried and showed.
Okay.
Yeah. Okay, that anyhow we can.
So it's a very cheap trick, so you just must go outside and it will work.
Yeah, mainly because of GPS.
Other questions?
Yeah.
Can you put the last slide so that we can note down your email addresses of that?
Okay. Yes, to just. And yeah, I can tell also. My email is RK Sharma. Very simple. It is Rajkumar Sharma, RK Sharma @SAC Space Application Center .isro.gov.in.
Sir, you skip one slide at 10 to 80 meter for wind speed calculation. So I want to know how that calculation is done, because regarding that I have some question. You will.
This is logarithmic process.
Power law.
Yeah.
So their alpha value is a much variable thing. So that's a complex thing. So how to get it's vary from every region, every site.
Why it should vary that much from each site to site?
Yeah, it's
Based on what? Because when we are taking the model is taking into account everything.
okay.
Never
So
the model will take into account everything.
okay.
I think we have time for one more question. Okay, thank you very much for this instructive talk.